Hello, mathematicians. This is Miss Armgart. Welcome to another instructional video. Today we're going to talk about inverse operations when we are doing addition and subtraction on equations. So, first, let's review, because we already know from our previous units that when we simplify, we go from the most complex down to the least complex. So you do addition and subtraction, summation and subtraction, you do that last, because you have to start at your highest level and go down. Now, when we are solving, so not just making it simpler, when we're trying to find the answer, it's the exact opposite. So solving, you go from least complex to most complex. So you're going to do addition and subtraction first. That's because the solving is the inverse. It's the opposite of simplification. I know that might not make sense now. So let's look at an example. So before we do that, we have to establish the inverse of each of these operations. So addition and subtraction are inverses because if I give you a pencil and then I take a pencil away, I've canceled it out. There's zero. You're left with the same part. So our addition is the inverse of subtraction. Let's look at this in practice. So we are going to look at these examples with the geometric model. So first we're going to look at the shapes, then we're going to look at how to solve it mathematically. So we have x plus 6 equals 45. So when you have addition, the number that you don't know, the variable, has to be smaller than what it's equal to, because you add two smaller numbers together to get a bigger number. So the 45 is the biggest part, because what's on the left side has to be smaller. Those two terms are smaller than the 45. So that means we know 6, we do not know x. Well, in order to figure out x, that is part of 45. 45 minus 6 is 39, because 39 plus 6 equals 45. So when you are adding your variable, that's what the model looks like. Now let's look at what happens when you are subtracting. So x minus 5.23 is going to be equal to 14.5. So in this case, x is the biggest thing, because if we're taking something away, x has to be the big box. It has to be the biggest part. So our other pieces, our other known numbers, are 5.23 and 14.5. So I've made them different colors because those two pieces will make up x. X has to be the biggest number. Well, then all we have to do is our addition, because both of those numbers make up x. So 14.5 plus 5.23 gives you 19.73. So all I've done here is show how did I figure that out with a picture. So addition versus subtraction, they are the inverse, okay? So let's see this with our algorithm. So the first thing that we are going to do is we are going to establish the operation. We are talking about addition. We have addition right there. The inverse of addition is subtraction. They're the opposite of each other. So in order to solve this, we first draw a line down the equals, because this equation has to be the same on both sides. It has to balance. It's a scale. So both sides have to be the exact same. So I look at my operation, then I do the inverse. Minus 6, and I draw my line. What I do to one side, I must do to the other. Now I bring everything down. So this becomes x plus 0 on the left. It is equal to 45 minus 6, which is 39. We can rewrite this, because we don't need the 0, as x equals 39. There's our answer. All right, so now let's look at our other equation. Now we have subtraction as our operation. The inverse we know is addition. Same process. Draw the line down the equals. We are going to do the inverse, so plus 5.23 on the left. What we do to the left, we do to the right. You'll notice my decimals aren't lined up. That's okay, because I know that 14.5 plus 5.23 will give us 19.73. That line still means equals. And now we have x plus 0 because that zeroes out. So we'll rewrite this as x equals 19.73. So if we go back, we got the exact same answer as our geometric model because we're showing that those two numbers put together equal the x. And we're showing that these two numbers taken away, the 6, the smaller one taken away, gives us our x. Don't forget to fill out your examples from the notes. And this is Miss Armgart saying happy solving.